Hello everyone and welcome back to another video. In today's video, we'll be going over an example for a process flow diagram question. This is a mass balance question that you might see in your chemical process calculations class. Let's go ahead and get started. A juice processing plant concentrates orange juice by evaporating water in a single effect evaporator. The feed stream contains 5 weight% solids and 95 weight% water, and the process is designed to produce a concentrated juice stream containing 50 weight% solids. The water removed from the feed exits as a vapor stream. Given the following information, calculate the mass flow rate of the feed, concentrated juice, and vapor stream, assuming the flow rate of the feed stream is 100 kilograms per hour. First thing first, I would like to draw the process flow diagram for this problem. So, as the question states, we have an evaporator. Let's call that E1. We have a feed stream. The feed stream, the flow rate is 100 kilograms per hour. And this flow rate consists of 5 weight% solids and 95 weight% water. Coming out of the evaporator, you have two streams. The first stream is the vapor stream. And we know that it's a vapor stream, so it's purely water. It's 100 weight% H2O. And we also have our concentrated solid stream. Let's call it P. And it's 50 weight% solids, 50 weight% water. So this looks good now. We have our system, we have the flow rate, and we have the vapor stream and the product stream coming out of the evaporator. So our process flow diagram is complete. We can move on to the assumptions and give it information. So this part pretty much details all the information that the question has given us. We know that this is a mass balance question. And in mass balance questions, we have to remember the conservation of mass law. Mass is neither created nor destroyed. So conservation of mass. Input equals output in this situation. It's not a reactive problem, so there's no reaction happening. So non-reactive system. That's another assumption. We have a flow rate, which is 100 kilograms per hour. We know what we have in terms of percentages in the flow rate. 5 weight% solids, 95 weight% water. We don't know our product flow rates or our vapor flow rate, but we know how much they consist of. So for product side, we have 50 weight% solid, and same thing for water. And then for the vapor stream, it's purely water. Great. So now that we have our assumptions and given information and the process flow diagram, we can go ahead and start solving for the problem. Input equals output in this problem. So let's start with the solids. You have the weight percentage of solid times by the flow rate will equal the weight percent of solid in product stream. So I'm going to just have P over here, and then you have the product flow rate. So we know the weight percent of solid in the flow rate stream, and I'm actually going to put an F in here as well. And the flow rate is 100 kilograms per hour. We know the weight percent of solid in the product stream, which is about 50%, so 0.5 times by the product stream, which we don't know and we're trying to solve. So the product stream will equal this, 10 kilograms per hour. So now we know that we have 10 kilograms per hour of solid. Now we know that we can solve for the flow rate problem. And what I mean by that is, remember, feed equals product stream plus vapor stream. The feed is 100 kilograms per hour. The product stream is 10 kilograms per hour. We don't know the vapor stream, but we can solve for it now. Vapor equals 100 minus 10 equals 90 kilograms per hour. So now you know how much water vapor is coming out of your evaporator. Now that we have solved the vapor stream, we have solved the problem. If you want to double check your answer, you can do the following. You have the amount of solids and the amount of water coming into the evaporator, and the amount of solids and the amount of water coming out of the evaporator. You can just make sure that the same amount are coming in and coming out, and then you know that you have solved the problem correctly. So let's take a look. For water, this is the following equation. Whatever coming into the feed stream is coming out of the product stream and the vapor stream. We do the math. 95 kilograms per hour of water coming in, 95 kilograms per hour of water coming out. We have solved the problem correctly. And for solids, it's the same thing. Five kilograms per hour of solids coming in, 5 kilograms per hour of solids coming out. We have solved the problem correctly. And that's how you solve a mass balance question. Thank you so much for watching. I'll see you guys in another video.